So today we will start a course on a network analysis and synthesis. It is a course prescribed in the electrical branch and it is in the 4th semester. So first I will introduce myself. I am Dr. Shweta, working in a electrical department in IET Lucknow, and I will just start with the basic introduction of this subject. So first we will see the content and the division of the marks of it. Subject code is KW403 and the subject name is Network Analysis and Synthesis. And for this course there are 3 lectures prescribed for it and the tutorial is 1. And the evaluation scheme is such that there is a 50 marks for the sessionals, in which 30 marks is distributed for the CTs and the 20 marks is for teacher assessment. So 50 marks will be evaluated on a sessional basis and the end semester marks will be of 100. So total contribution for this subject is of 150 marks and its credit is 4, right? So what are the prerequisite courses for this course is basic electrical engineering, which you have already studied in the first year, maybe in the first semester or the second semester also. So basic requirement is you should know the basic concept of your basic electrical engineering, and the next is the basic signals and system. Basic signals and system you have covered in your 3rd semester, I guess, right? So these 2 courses is must. We should know the basic concept of these 2 courses, which is prerequisite for the network analysis and synthesis. So these are the 5 COs which is made based on your units, right? So first CO is for the unit 1, second CO is the unit 2, and similarly all the 5 COs are made based on your units, right? So first is the apply the knowledge of basic circuit laws, nodal and the mesh methods of circuit analysis and simplify the networks using graph theory. So basically it is the graph theory unit, right? Second is the analysis. It is the analysis of the AC and the DC circuit using Kirchhoff's law and network simplifications theorem. So as you have already studied the analysis of the networks in your basic electrical engineering, but in which it has been already covered in a DC signals, right, DC networks, but in which you are going to deal with the AC and the dependent source and the independent source, how you are going to deal with the theorems and how you are going to simplify a network, right. Third unit, which is going to contribute for your course outcome 3, is the analyze steady state response and the transient response of DC and the AC circuit using the classical and the Laplace transform methods. So here the basic signal system course is required, which you have already covered the Laplace theorem in your basic signals and system, right. So basically it is steady state response and the transient state response for your AC and the DC networks. Course outcome 4, that is will be based on your unit 4. It will demonstrate the concept of complex frequency and analyze the structure and the functions of 1 and 2 port network, also to evaluate and analyze the 2 port networks parameter. So basically 4th unit is dealing with the 2 port network and the 1 port network also. Last unit is containing your network synthesis part. As the name suggests, it is a course networks analysis and synthesis. So networks analysis part has been covered in all these units. By different methods you are going to deal with it, and the synthesis part, synthesis part is going to be covered in the unit number 5, which will contribute for your CO5, that is synthesis, 1 port network and analyze different filters, right. So we will deal with all the units one by one. So basically this is the course, this is the first lecture of this course. So we will deal with just a basic concept of it and we will revise some basic properties or basic elements which is prerequisite for your study, right. So what is the network and what is the circuit? First we will see the difference between the networks and the circuit. So if we see the network, it is any arrangement of energy source and the circuit element is called a network. It is an arrangement or interconnection of any energy sources and the circuit element is your network. So we will see energy sources, it could be a voltage source also, it could be a AC voltage source also, it could be a DC voltage source also, right. And the next energy source will be your current. So current will be shown by this, right, if it is a independent one, right. So it is a arrangement or of energy sources and the circuit element, and the circuit elements will be elements that is having R, L, C if we are dealing with the electrical, and if you are dealing with the electronics, then electrical circuit elements could be a diode, your SCR, or any electronic devices also, right. So this is the circuit elements and these are the energy sources. So basically it will be a combination, it will be the interconnection of your energy sources and the circuit element is called the network, is called a network, right. So it could be like, if for example I am just connecting a source and I am connecting a electrical circuit element, that is R, L and C, right. I am not closing it, it is a voltage source. So I have been, this is R, this is L and this is C, right. So I am just interconnecting your voltage source, a resistor, a inductor and a capacitor in a series manner. So this is a network, right. So there is no compulsion that it should be a closed or it should be open. Any interconnection we can say it is a network, right. Now the second definition for the circuit is a combination of elements like a resistor, like electrical circuit element we have taken resistor, inductor and the capacitor along with the sources. Basically it is an electrical source, but it must be a closed one. This is the necessary condition for the circuit, right. So this is the basic difference between network and a circuit. Network could be a open circuit, could be a closed circuit, but for the circuit must be a closed one. It is also a connection of your circuit element and energy sources, but it should be a closed one. So this is the electrical network, this the figure which I have shown, this is the electrical network, but since it is not closed, so we cannot say that it is a circuit, it is a network. So if we just close it, then it will become a circuit, right. So with these two definitions we can say that all electrical networks are not electrical circuit, right. As we have just made a network, it was not closed, so we can say this electrical network is a network, but it is not an electrical circuit. But since it is a circuit, now it is also verifying this condition that it is an arrangement of energy source and the circuit element. It is a arrangement of energy source and the circuit elements. So all electrical circuits are electrical networks, but all electrical networks are not electrical circuit, right. So this is the basic difference between networks and a circuit. Next we will see what is the network analysis. We have just bifurcate the topic or course, we can say network analysis and synthesis. So first we will see what is network analysis, next we will see what is network synthesis, right. So first is the network analysis. What is network analysis? Network analysis is a process or a technique by which we can calculate different electrical parameters of circuit elements connected in a electrical network, right. We will see with the example also. This is the definition, that it is a process by which we are going to calculate different electrical parameters of a circuit element connected in a electrical network. Now what are the electrical parameters will be? Current, voltage, resistance, impedance, reactance, inductance, capacitance, frequency, electrical power, electrical energy, etc. This could be your electrical parameters which we are going to calculate in a circuit element connected in electrical networks. The technique, the process is called the network analysis, right. So for example, I am just making a circuit. I can say this is a circuit, right. This is a voltage source, AC voltage source, this is R, this is C and this is L, right. Now as we can say, it is an electrical network. Up to here it is a circuit as it is closed, but here it is not closed, there is no closed loop here, right. So we can say up to here it is a circuit, but this whole is a network, right. So if we have to analyze this network, means we have to find some electrical parameters across this element, circuit elements, right. Suppose we have to find a current in this network. So current will flow only in this direction, it will not flow in this because the loop is not closed. So current I will be 0 here, right. So we are calculating, we are analyzing this circuit, this network, and calculating some electrical parameters. Here our electrical parameter is current, right. So we can calculate the current across this resistance also, we can calculate the current across this capacitor also. We can calculate the current across this L also, but since it is not a closed loop, so the current will be 0, right. So this is how the network analysis is done, right. Now next topic is the network synthesis, right. Network synthesis is a designing techniques for the linear circuit elements. It is a designing technique, as the name is including synthesis part, it means we have to creating something, we are going to design something, right, we are going to synthesize something. So basically we have given some impedance functions of frequency or frequency response, and based on this parameters, based on this impedance function of the frequency or frequency response, we are going to design a network which will produce the required response. Whatever the response is required, we are going to design a network by which the same response is given, right. So synthesis is basically determined by a impedance function or a frequency, some function is given, and from that functions we will determine a possible network. Possible network means it could be a connection of different elements R, L, C, or some other sources also, some other energy sources also, some other circuit elements also, and in which fashion they are connected in series, parallel, or in whatever combination, possible combination, and the short combination it will be, that will be dealing in the synthesis part, right. So basic requirement for this synthesis is your impedance function which will be given, or the frequency response which will be given to us, and based on that frequency response or function we are going to synthesize a network that will produce the required response. So this is the basic introductions, right. When we deal in the 5th unit network synthesis, it will be more clear, right. Now what are the linear elements? As the name suggests, linear means there is some linear relations between two variables, right. So basically the voltage and the voltage across the two terminals is directly proportional to the current through the element either in the time or in the frequency domain, right. What it means, if suppose here is an example of resistor taken, I am just making a resistor, these are the two terminals A and B, and the voltage across this resistance is VAB, and the current flowing through this resistance is I, right. It is saying that the voltage across the two terminals, that is A and B, that is VAB, is directly proportional to the current which is flowing through the element. What is the current flowing through this element? This is I. So it is saying the voltage across the two terminals is directly proportional to the current through the elements either in the time domain or in the frequency domain. That element is called the linear element, right. So in the resistor, as we can see the ohm, we already know the Ohm's law, that is saying V is directly proportional to I, that is V is equal to IR. So we are here seeing that there is a linear relation between V and I, and it is in the time domain, right. Clear? It is the time domain, it is linear relation between V and I. So resistor is a linear element. Next is the inductor. For inductor also, I am just making an inductor. The current flowing through this is I, and the voltage across this is V, right. So we already know this relation VT, V in the time domain is equal to L di by dt, right. So as we can see in the time domain, it is not linear. V is directly proportional to the differentiation of your current, right. So if we take the Laplace transform of this equation, we will get V of S, that is the Laplace transform of this voltage, is equal to L into SI, right. It is in the frequency domain. We have taken the Laplace transform. By seeing this equation, we can say that V is directly proportional to your I, right. So there is a relation, there is a linear relation between V and I in the frequency domain, right. There is a linear relation between V and I for the resistor in the time domain, but for the inductor there is a linear relations between V and I in the frequency domain, right. Similarly, for the capacitor is also I is equal to C dV by dt in the time domain. If we take the Laplace transform of this equation, we will get I is equal to C into S V of S, right. It is in the Laplace transform, it is in the frequency domain. We can see this I is directly proportional to this V, and there is a linear relation between I and V. So, it is in the frequency domain. So, R, L, C, all three elements are a linear element, right, because they are following a direct proportional relation between V and I either in the frequency domain or in the time domain, right. Now, what is the non-linear element? Linear is directly proportional, non-linear means not directly proportional. So, the voltage across the two terminals is not directly proportional to the current through the elements either in the time or in the frequency domain. For example, if we take the diode, this is the relation between I and V. I is equal to I naught exponential of QV by eta of KT minus 1, right. So, here is the V which is across your diode. If we make a diode, this is voltage across this diode and the current flowing through this is I, right. This I naught is the saturation current, right. So, this equation is written in the time domain. As you can see, this current is not directly proportional to this V, it is in the exponential relation. If we take the Laplace transform of it also, it will not going to be proportional in the frequency domain also. So, either in the frequency, either in the or in the time, in both domain, this voltage across the diode is not going to be proportional to the current which is flowing through it, right. So, diode is a non-linear element. Similarly, we can say all the other electronic devices also, they are of non-linear nature. So, they are non-linear elements. Now, the next topic is the unilateral elements, right. As the name suggests, it is a unilateral, means there will be a flow of current in one direction only. For example, we have taken a diode and a SCR. We will similarly take the diode example. We are making a diode. We already know the VI characteristic of it, right. So, when the polarity of the power supply voltage is changed or reversed, either it opposes the flow of current or shows a different property, right. This is the property of the unilateral elements. As we are taking the example of a diode, so we already know the VI characteristic of it, right. So, if it is the anode, cathode, so voltage across this will be VAK and the current flowing through it is IAK, right. So, if we just plot the VI characteristic which we already know, it is a kind of this nature for the forward bias condition, and for the reverse bias condition it is like, it is going for reverse saturation and it will go like this, right. So, this is the knee voltage, right. So, when the voltage polarity is going to be changed, its property is going to be changed, right. So, it is not, diode is not behaving in the similar fashion as the voltage is getting reversed, right. So, it is only allowing the flow of current in one direction. It will allow the flow of current only in one direction only, right. Right. For the forward bias condition, when this anode is connected with the positive terminal of the battery and this cathode is connected with the negative terminal of the battery, right. Similar nature is with the SCR also, right. Next, we will see the bilateral elements. So, as the name suggests, it is a bilateral, means it will allow the flow of current in both direction, right. So, allow the flow of current in both direction, and when the polarity of the voltage is getting reversed or interchanged, it will not show any different property to the flow of current, or in other words we can say it will allow the same amount of current to flow in both the directions. For example, if we take the resistor, if it is connected with a AC source and the current is flowing through it, right. So, for the V and I, if this voltage is positive, this voltage here terminal is negative, the current will flow in this direction, and if the polarity is changed for the next half cycle, this is negative, this is positive, it will not affect the flow of current, it will not change the flow of current, it will not affect the current, it will just reverse the current. Now the current is going to flow through this direction, right. So it will just flow of current in both the direction, it is not going to alter the properties, right, of the flow of the current when the voltage is getting reversed or interchanged, right. Now energy sources, we will just see the energy sources, right. Basically we are dealing with the network analysis and synthesis, so we will deal with the electrical energy sources. What are the electrical energy sources? There are two types of it, we can widely define it. First is the independent source, second is the dependent source, right. Independent sources further classified into voltage source and the current source, right. This voltage source can be either ideal or the practical. Ideal means we are not going to get in the laboratories or in practical purpose, it is just an ideal one, right. Current is also having classified into two parts, that is ideal and the practical. Now the dependent sources has been classified in the four categories, that is VCVS. It is a voltage controlled voltage source, right. Voltage controlled voltage source, voltage controlled current source, current controlled voltage source and the current controlled current source, right. We will just see it in a brief. This is the table made for the classification of the voltage and the current source. Independent sources has been classified into voltage source and the current source, right. So ideal voltage sources are the sources that in which the load voltage is independent of the load current, right. Based on the load, the current value, the voltage is not going to be affected. For example, we can see it here, this is V and this is I, right. For all values of your current, the voltage is constant, it is not going to affect by this load current. See, this is the ideal nature of the ideal voltage source, right. Now the current source, ideal current source is the source in which the load current is independent of the load voltage. Load voltage is not going to affect this current, whatever the load voltage will be here, the current is going to be constant for all the load voltages, right. This is the ideal condition. Now for the practical voltage source is the ideal voltage source in which a series resistance or the internal resistance is connected, right. This is the ideal voltage source, a series resistance is connected in series with it. We can say that Vt is equal to V of S minus I into Rs, right. So if we plot Vt versus I, this I is going to increase, then this V is going to decrease. That is why when this I is 0, Vt is equal to Vs. As this current is going to increase, this is going to fall like this. This is the practical voltage source. Similarly, for the practical current source, it is the ideal current source in parallel with the internal resistance. Here the internal resistance is in a parallel. This is the ideal current source. A resistance is connected in parallel and this is the voltage. So here I is equal to Is minus V by Rs. So here as the voltage is going to increase, this I is getting down, right, because it is a negative sign. So this is how we can classify ideal voltage source and the practical current voltage source, ideal voltage source, ideal current source and the ideal voltage source, right. So in the next lecture we will continue from here. Thank you.